Hi, I am Jagdish M, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, in our optical microwave video lecture series, we are going to discuss about the topic optical fiber structure. Come, let's dive into the topic. Before getting into the topic, let us see the presentation overview. So I will start from what is the need for optical fiber, and then what is optical fiber actually, then structure of optic fiber, working principle of optical fiber, then classification, block diagram, advantage, drawbacks, and applications, and finally we will end up the session with assessment. Okay. So, before getting into the optical fiber, what is optical fiber? Let us see what's the purpose of optical fiber. What's the need of optical fiber? See, we know very well that the communication means that sharing the information from one place to another place. So, this is common thing. But what kind of a medium we are using? If we are using a wire, that's a normal copper wire, that will be transmitted in terms of electrical signal. But in the case of optical fiber communication, the signal will be transmitted by means of light. So this is the biggest advantage because we know very well that the light has the highest velocity, very good speed when compared to other signals. So this is the main reason why we are going for this optical fiber communication. So and again, next reason is it has a higher bandwidth because it supports up to the terahertz frequency range. This is another thing why we are going for the optical communication. Then low attenuation, that is loss in the optical fiber communication is very very less. So these are all the things why we are going for this optical fiber communication. So next, let us see. You can see this comparison, right? Here I have compared the copper with optical fiber communication. So in case of so the cost, life cycle, distance, weight, energy consumption, maximum bandwidth, security, in all the aspects, the optical fiber is so far better than the copper. So that's why we are actually considering the optical fiber than other medium. So next, let us see what is optical fiber. So optical fiber is actually a very thin cylindrical fiber. It's like a hair, our human hair of glass or any other transparent dielectric medium. The function of the optical fiber is it is actually a one wave guide. Wave guide means it will guide the signal. That means here the signal means that the light. So the light means visible light or infrared light over long distance. So it will guide the light signal to the particular destination. So you can see the image, you can see, right? So this is the optical fiber where this the laser is shown in front of the fiber thing, right? So it is traveling through this optic fiber, right? And next, the structure of optical fiber. So, as far as the structure of optical fiber is concerned, here there are two important things. One is core, another one is a cladding. This is the two important things. So, where core is the main part where the signal will be propagated, where the light signal is propagated, and the cladding is the outer part of the core, where when the core when the light is reflected, so the cladding that will reflect this signal again to the core. So this is the function of the core and cladding. And other than this core and cladding, we have several coatings are there. Outer jacket is there, so that is used to protect the fiber optic link from the external disturbances. So as I said, the core is a central region that carries light, and cladding is nothing but an outer layer that surrounds the core and reflects lights back into the maintained signal transmission. Then another coating is that's called a buffer coating. It's a silicon material, so it is used to protect the fiber. So when it comes for the there's a working principle of optical fiber. It works on the principle of total internal reflection. Means total internal reflection means where the light signal entering the fiber core and reflected repeatedly by core cladding boundary, allowing the light to travel through the fiber with a minimal loss over long distance. So you can see. So this is actually in this image. This is actually a fiber optic where the outer part I already said it's a cladding, and the internal inter part, right, there is a green color one uh, pipe shape image is nothing but of a core part. So this yellow color is a light. So light which gets the reflection in the core part, and finally it will reach the destination point. So this is called a total internal reflection. So the basic principle of total internal reflection only it is working. The optical fiber communication is processing. And so let's have some classroom activity. So we already arranged some groups, student groups. So here the two images are shown in this PPT. It is actually a rebus puzzle where you know very well that rebus puzzle is a collection of words, symbols, images, and from that you have to find out the word. Okay, so you have two set of images as there. So let us see who will be going to crack the answer for these two rebus puzzle. So let's resume this session. So when next thing is classification of optical fiber. So classification means here we have two classifications, two categories. This based on number of modes, and another one is based on refractive index. So based on number of modes, we have two things. One is single mode fiber, that is SMF. Another one is a multi-mode fiber. Based on refractive index, we have two classification. One is step index optical fiber. Another one is a graded index optical fiber. So let us see what is single and multimode fiber, optical fiber. So single and multimode optical fiber, you can see in this image, you can see that in a single mode, there's only one light path. So, okay, so only one light path will be there. So the signal will be propagated for a long distance. When you are coming for the multi-mode, it has a multiple light paths. So the signal will be bounced back, different. It will travel for the different paths, and it will reach the destination where it supports only for the short distance communication. So this is the difference between single mode and multi-mode fiber. And another category is step and graded index fiber. So step index fiber has a core with a uniform refractive index, whereas grade index fiber has a core with a gradually changing refractive index. So that is the difference. You can see from this image that is depicted clearly. So this is the block diagram of optical communication systems where we have an information system, because information system may be in any other form. Okay, if it is in a electrical form, that electrical form information should be converted to a light form, that is a optical source. Then optical source will be given to the optical fiber cable. That optical fiber cable consists of a coating, cladding, then core part will be there. Then again will be given to the optical detector, where the optical detector will convert the optical signal, that's a light signal, to electrical signal and given back to the electrical receiver. And finally, the receiver end will be receiving the data in an electrical form. So this is the complete block diagram representation of our optical fiber communication systems. So let's see the advantage and the drawbacks of optical fiber communication. As already in the very first slide, as we said, it is an immense bandwidth, it's a higher bandwidth to utilize, and very low attenuation noise, and a low transmission noise. And another one is a small size and lightweight, higher signal security, then very low power consumption and wide scope of system expansion, then resistance to noise, and high signal carrying capacity, because it supports up to the terahertz frequency range. So it has a higher signal carrying capacity and long distance communication. Then we'll look into the drawbacks. Though it has several advantages, in any technique, any technology, that obviously we will have a drawbacks also. Here in optical fiber communication, we have set of drawbacks. That is, first one is installation is costly. Then another one, it only supports for point-to-point communication. And the next thing, fragile, and it can be easily damaged, since that is very small and compact, right? So it can be easily damaged, and not all the devices is suitable for this optical fiber communication. And when look into the applications of optical fiber, actually we cannot narrow down the optical fiber applications, because the optical fiber communication, which deployed in a wide range of applications. I have taken only one thing, that is a optical fiber optic plasmonic sensor in this sensor, which is being used in several applications like medical diagnostic, chemical sensing, temperature sensing, environmental monitoring, pressure sensing, force sensing, etc. Like that. There are several applications are there, and a very familiar application is in a telephone, landline telephone line is being used by the optical fiber communication. And finally, let us see the assessment. So far we have discussed what is optical fiber and what is the need of optical fiber and optical fiber structure, types, and the process and block diagram, everything we have seen. From that topic, let us see how much you have understood the topic. So let us take this puzzle as an assessment. You have the questions across and down questions is there. You just fill up for each question. You find out the answer and you fill up the correct words in the box provided. Right. So let us see who will be giving the correct answer first. So thank you. So in the next session, we will discuss about the optical fiber platforms. Thank you.